All right, we're going to look at the last couple here. I'm only going to do a few of them. We'll do 6 and 8. So 6 and 8. And rotating 270 around the origin. So remember, always the origin, use our rules. The rule for 270, go back and look at that page. It's always a good idea to have that page handy. 270 is negative y, or x negative y. So you're going to change xy to y negative x. You're going to keep the y number and just and bring it to the front, and you're going to change the x to a negative, or to its opposite. And then to reflect it in the line y equals x, you just flip it around to yx. But we got to flip these points around to yx, okay, not the original points. So you got to do one step. So this will be step 1, this will be step 2. So you're going to take m, and m right now is the point 3, 4. Okay, so that means that m prime is going to be, you're going to bring the y up front as a 4, and put the x in the back and make it its opposite, negative 3. And then m double prime, you're going to just switch those two around. So it's going to end up at negative 3, 4. So you're switching these two around to get your m double prime. So 4, negative 3 would be here. That's m prime. And then negative 3, 4 up here is your m double prime. And we'll show you how that works. Let's do n next. The actual point for n is 3, 1. So you take n prime by doing this first rule right here. The first rule says bring the y up front and leave it 1, and put the x in the back and change its sign. So 1, negative 3. And double prime says to take that point and switch them around, because that's what it says, just to do yx. So negative 3, 1. So let's plot those two. 1, negative 3. Be right in the middle there. That would be n prime, and that's going to connect to m prime. So that would be what we call a 270 rotation. I'll show it to you. And your m is going to rotate 270 degrees. It's 3 quadrants. You're going to rotate it 3 quadrants. N would also rotate 270 degrees, 3 quadrants. I'm not going to leave those there. I just wanted you to see that's what would happen. And double prime is negative 3, 1 right here. M double prime, and if you connect those, that is a reflection across the y equals x line right in here. If you drew that line in, this one right here is going to reflect perfectly on that one right there, especially if you turn it vertically, so you see that the y equals x line is vertical. You'll see that those two will fold directly on top of each other. So those two would be a perfect fold. So you can try 7. I'll give you the 2 rules that you would need. For 90-degree rotation, you're going to use negative yx. And then for this one, you're gonna do a minus 5. And then you're going to do y plus 0, or just y. So just subtract 5 from whatever your x number is on the after the prime, and then keep the y. And if you need help on it, just get help. I'll come up and I'll be happy to help you out. Let's look at number 8. So let's graph the original j. J is 2, 3. So let's see, over 2 and up 3. We'll call that j. K is 1, negative 1. And L is negative 1, 0. So J to K to L, back to J. Okay, that's the triangle. They want us to do 2 things. First, they want us to change both signs. Then they want us to reflect it across x equals 2. We'll have to just see graph on that one. There's no rule for an x equals 2. You'll just have to count. But we could do the prime points. So J prime is going to be, we want negative x, negative y. Sorry, we're changing both signs. A 180 rotation is just changing both signs. You're not switching them around, just change their signs. So -2, -3. K prime is 1, or -1, 1. And L prime is 1, 0. So let's plot those. -2, -3. That would be here. That's going to be J prime. And then -1, 1. That's right up here. That's K prime. And then L prime is 1, 0. So that's L prime. If I connect those, actually, you know what? Let me connect those in a different color so you can see the difference between the two shapes. That's just a rotated shape. It's the exact identical shape, but you're taking the point and rotating it 180. It's an exact 180 rotation. When you draw in a 180 rotation, it's a half a circle. So you can see we rotated it a half a circle there. Now let me draw in, I'll do it in green here, the line x equals 2. It's got to go through the x-axis at 2. So we're going to need to rotate the red one over that line, and it's going to go off our graph a little bit. Let's make it purple. You can see L is 1 unit away, so we're going to need to go 1 unit away here. So that's going to be L double prime. K is 1, 2, 3, so we got to go 1, 2, 3. So K double prime. It's going to be up in our writing there, sorry. J is 1, 2, 3, 4 to the left, so 1, 2, 3, 4 to the right would be J double prime. So your triangle would be out here. So those would be the points that I'd be asking for, the double prime points. Where would it end up? So look we went from blue to red by a rotation, and then we did a flip across the green line and made the purple one. The purple one is where the shape would end up. That's what they're going to be asking you for. Determine whether it has rotational symmetry. It would be if you could put a dot in the center, and if you could turn this shape, would it land on itself? And you would say yes. And I would say 360 divided by 5 equal angles. If they have equal angles, you're going to be able to do that. 360 divided by 5 is 72 degrees. So every 72 degrees, you will have rotational symmetry. Every 72 degrees, it will look identical to that one. You'll have the same exact shape. This one will be on top, and then this one will be here, and this one will be there, and this one will be there, and that one will be there, and it'll look identical every 72 degrees. This one does not. There's no equal angles. So that's not going to have rotational symmetry. You put a dot in the center and you rotate that around that dot, you're never going to look the same until you go 360 degrees. So that's not rotational symmetry. All right, there's 4-3.